Is class night going on? I think sir is yet to come.
Wait a minute, wait a minute. Good afternoon, students. Yeah. I just want to share this screen. Let me open the contents. Is it visible to you?
Yes, sir.
Yeah, ultrasonics. So I'm focusing on expected essay questions as well as the short also. So that's why I am skipping a few of the questions. Okay, you can prepare later on. So in this ultrasonics, you need to know about the what are the ultrasonics and the production of ultrasonics. Two methods are there. One is the electrostriction method and the magnetostriction method. So out of these two, 100% one question is going to be given to you. If the examiner is going to give any question from the ultrasonic means questions from 12.2a or 12.2b, electrostriction method or magnetostriction method. That means how we are going to produce the ultrasonics here. Next is the detection. So four methods are there. Any one or any two may be asked as a short question. By combination, that means by combining two methods, they can ask as a S question. Okay. Is it clear? Next, the final one is the applications of ultrasonics. That is the important short one. Important short question. That's it. So we will go through the here ultrasonics introduction. That means here sonics are there, infrasonics, ultrasonics, and supersonics. So here sonic means which is related to the sound. So here, which you can able to hear the frequency range is 20 hertz to 20 kilohertz. So in this range only we can able to hear this sounds here. Okay. So here the human eye here uh, that can depends upon this range means 20 to 20 kilohertz. Okay.
Particular.
Yeah. So this is the most important objective bit when you are going to write any group exams or any competitive exams are there. There they are going to ask as a audible range. Indirectly, they are going to ask that here 20 to 20 kilohertz. So this you can able to observe in the case of LCR also. RC. Do you done this experiment? Coming year, second year, final year, you can able to observe this frequency range also, mid range that you can call it as 20 to 20 kilohertz. Next, other one is their infrasonics, which is less than the 20 hertz. Those are infrasonics, and above the 20 kilohertz are you can call it as a ultrasonics. So these are not.
Ultrasonic.
And also other one is there supersonics. Okay. So which the are nothing to do with this limitations of the frequencies 20 to 20 kilohertz, and supersonics which are associated with the velocity of objects like aeroplanes. I think so. You may
Aeroplane drop.
rockets. Okay. Yeah. Supersonic velocity. Those are going to be launching to the space from the Earth. So if the velocity of an object which is greater than the velocity of sound in air, then such velocities are said to be supersonic velocity. Is it clear? Next, so here infrasonics, ultrasonics, audible human ear audible range is 20 to 20 kilohertz. You can able to hear, but who they can hear these sounds here? That means cat, dogs, bats. These can listen the ultrasonics up to 150 kilohertz. Okay. Above the 20 kilohertz, you cannot able to hear these sounds. But above that much, up to the range, 20 kilohertz to 150 kilohertz, they can hear cat, dog, bats, like that. Okay. So here, there are many uses of ultrasonics like ultrasound scanning in medicine. Okay, you can hear that something in your digestive system, something is happened means how they are going to be identify that something means here ultrasound scanning. Okay, so they can easily identify by sending these ultrasonics. What are the defects? What are the how we are going to be, what type of say here inside your digestive system, so intestine, so whatever it may be here, they can easily identify that by sending these ultrasonic sounds. And also geological prospecting, there you can identify that. And seismology which is related to the earthquakes, fishing, and also measuring speed of object like car, the cricket balls. So there we are using these ultrasonic sounds. So these have high energy with higher frequencies. Okay, about 20 kilohertz. So these are material waves which cannot travel in vacuum. So identify this. And these can show the properties like reflection as well as the refraction. What do you mean by reflection? What do you mean by refraction? Hello? Anybody?
Reflect, reflection means returning back.
Yeah. From any smooth surface is concerned, there if it is going to be incidenting, and the incident ray which can travel in the same media in other direction, then that you can call it as a reflection. But what about refraction?
Refraction means when it is the traveling in different media. So
Yeah.
it will divert itself.
Yes. If you concern it normal, if it is going to be incidenting, there the ray which can bend from the one media into another medium, then that is related to the refraction. So both these properties which are related to the ultrasonic signal. And also they produce interference and diffraction. Interference means to such a frequency or intensity of light which are going to be superimposed here, then interference is caused. What do you mean by diffraction? Diffraction means, tell me, why because of here fourth sem, you have to read out all this. So diffraction means in any obstacle, the light ray which is going to be incidenting at the edges of the obstacle, which can bend and enter into the geometrical shadow, that you can call it as a diffraction. In the case of diffraction, you can able to observe the variation of intensities. In the case of interference, bright and dark fringes is going to be observed. In diffraction itself, you can able to observe the interference. Getting my points? समझ में आ रही बाबू అర్థమవుతుందా అర్థం కావట్లేదా they get absorbed in gases liquids and solids. These are also going to be get scattered, and ultrasonics can be transmitted to travel long distances, and these can also produce heating effect when they pass through the medium. Okay, so here these are the production of ultrasonics. So usually we can go through the two methods here, producing the ultrasonics for a since long time. One is the electrostriction method, another one is the magnetostriction method. Be careful, any of these one essay is compulsory. Production of ultrasonics. So this electrostriction method, which is also called as a anti-piezoelectric method, and anti-piezoelectricity, which is going to be producing a mechanical vibrations, okay, an application of electricity, and which is also known as electrostriction method. So Pierre Curie, okay, so in 1880, so discovered that crystals, so many crystals are there: calcite, silica, glass, quartz, tourmaline. So many crystals are there. So in 1880, he discovered that in quartz crystal, when a mechanical pressure is going to be applied to this crystal in only one direction, then electrical charges appeared in perpendicular direction to it. So what is going to be observed here? Mechanical pressure is applied in one direction perpendicularly. There is a electrical charges which can appear. So this you can call it as a piezoelectricity, and which is due to the disturbance of electrical symmetry of the crystal. So other crystals also there, that is rockly salt, tourmaline, ADP, DKT, EDT. So many crystals are there. These are the single crystal, and some popular polycrystalline materials, that is the ceramic, barium, titanate, lead, zirconate, titanate, and uh, PZT, you can call it as. That means P. So Z means zirconate, T means titanate. PZT are piezoelectric materials. So a metal coated polyvinyl difluoride, PVDF. So what do you say? Polyvinyl difluoride. and lead-free, uh, sodium, potassium, niobate. So N means sodium, K means potassium, N means niobate, NKN. So these are later additions to the piezoelectric materials. So these are only, it can produce the here electricity by applying a mechanical pressure on it. So that was observed by Pierre Curie. So that mm, uh, recent research which have been find out the dry bones also exhibit the dry bones. Okay, these are also going to be exhibit piezoelectric properties, and other organic as well as the inorganic biological materials, which is also going to be shows the piezoelectricity. So these are the crystal here. What do you say here? This is the crystal, and whereas this is the X cut crystal, this is the Y cut crystal is there, and here uh, you need to know about that. Uh, these piezoelectric, when they are going to be using in ultrasonic transmitters, these you can call it as a transducers. What do you say? Transducers. So these transducers are synthetic PZT and X-cut plate. So just now I show you what is X-cut, what is Y-cut. X-cut plate from a natural quartz crystal. So here you can able to find out that here the attenuation, the understand how X-cut plate of a quartz, which is going to be used as a transducer. And this natural quartz is a hexagonal crystal. You can find out that the shape, which is a hexagonal shape here. So this, which is a with a pyramid on both sides of length, and this has a 6 sides. Hexa means 6 sides, and the line joining the midpoints of center of opposite sides, we can call it as a y-axis, and which is also known as mechanical axis. This one, mechanical axis, and the line joining to opposite corners of x-axis. Okay, opposite corners of x-axis, which is nothing but a here, and what do you say? Electrical axis. So here the length of quartz crystal, which is perpendicular to the XY plane. X is the electrical, Y is, what do you say here? Midpoints. Then which is also called as the Z axis. This is optic axis. Okay, in SSP solid state physics, you can clearly you can able to read out that known the phenomena of what is a X cut, what is Z cut, and what is Y cut. So you can easily find. So our aim is that how to produce the here ultrasonics by using these crystals here. Let us discuss that a quartz plate cut with a thickness perpendicular to the x-axis, and length along y-axis, and width is along z-axis, x, y, z. So the quartz crystal is to be considered here along x, y, z. So here, which is known as X-cut quartz crystal. So which is capable to produce the ultrasonics, longitudinal vibrations. And if an AC, that means alternating current or a voltage of a suitable frequency, which is going to be applied along the x-axis, x-axis usually you can call it as electrical axis, then you can able to observe the vibrations with the stress and the strains, which are going to be set up to the crystals here, so that which is going to be oscillates or which is going to be vibrates here with such a frequency. That means you can able to find out the whether the crystal is going to be elongated or contracted. That you can able to observe along the y-axis. That means here x and y both are perpendicular to each other. So the definition of which is related to the here the Pierre Curie, he is observed that here along the x-axis, if mechanical or you say vibrations are to be applied along other direction, you can able to observe the here vibrations. So electrical signal is going to be applied. While so in this case also, we are applying the electrical signals along the x-axis so that the crystal is going to be vibrate so that you can able to observe the crystal nature here. So elongation or contraction. So in which direction you can able to observe along the y-axis. So that if the AC frequency, that means you are applying alternating current now. So the frequency of the AC, which is equals to the natural frequency of the crystal. Okay, please underline this. The applied frequency, that means here AC 50 Hertz, suppose. So here if it is equals to the natural frequency, that means the same phenomena you can able to observe in the case of a sonometer. Okay. So or else volume resonator experiment. There you can able to observe that the frequency of the tuning fork, which is equals to the natural frequency of the air, then what you will observe, resonance is going to be takes place. In the case of resonance, maximum vibrations. అవునా కదండి? అర్థమవుతుందా బాబు? నాకు నేనేదైనా చెప్పుకుంటున్నానా ఏంటి?
Yes, sir. Yes, sir.
Yes, sir.
Yesterday we have done the practical also.
So that if you say something, so that in detail I can explain. Otherwise,
Yes,
so that is the case of volume resonator. So, and also in the case of sonometer also, such a frequency, you are hitting with a frequency with a rubber hammer to the tuning fork, and you are keeping on the sonometer apparatus. So that what you will observe here, at such a resonating length, such a resonating, underline this, the paper writer is going to be fell down. That means here what will happen here, the frequency of the tuning fork, which is equals to the frequency, natural frequency of the air, where it is in the bowl of the sonometer.
in between of the blocks.
Yes, yes. There you can, air is there, medium is there. So that the paper rider is going to be fell down, then means you can find out the resonating length. The same phenomena is also going to be applied in the case of here, piezoelectric effect here. So that means applied frequency, that means voltage of a signal, which is equals to the frequency, natural frequency of the crystal. Then what you will observe here, with a maximum vibration, maximum vibrations. So that resonance is going to be takes place here. That means the crystal is going to be either elongated or contracted. So with such a higher vibrations, that means the resonance is going to be caused. So in that case, you can able to identify the here ultrasonic. That means the crystal which is going to be produce the ultrasonics. So that here the equation part which is related to the frequency of the corresponding longitudinal vibrations, F equals to K by 2T under root Y by rho, Y by rho. So where K you can substitute is a 1, 2, 3 and so on. So that for K equals to 1, fundamental vibrations and other harmonics, and it is the thickness of the quartz plate, where Y is the Young's modulus here. And that value is 18 to 10 power 8 Newton meter square, Newton per meter square, and rho is the density of the quartz crystal. So using all this, by substituting there, where T is the thickness, that is not written here. Okay. So here, this one. So T is the thickness here. So you can easily calculate the here the fundamental frequency of 1 mm thickness of X-cut quartz crystal plate. So that is the frequency is 2.747 megahertz. Mega means hello.
10 power 6, sir.
10 power 6, sir.
Very good. So this is the case. So that so piezoelectric oscillator. Okay. So you can here You can see that this is the primary section and this is the secondary section is there. So this is the circuit. You need to draw this. Here is a tank circuit is there. This is the tank circuit, LC combination. This is the capacitor variable is also there. This is a transistor. And here two coils are there, L1 and L2. L1 and L2 are the two coils. S is a switch here. This is the DC supply and this is the ground. And this is the primary section. And whereas in the secondary section, this is the secondary section, another coil is there. And here we are keeping the quartz crystal between the A and B. Between the A and B, we are keeping. So that what are these? These are the vibrations. So that these are going to be resonating vibrations. That means you can easily identify that here whether the crystal is going to be elongated. Elongated means length should be increases. Contracted means length should be decreases here. Okay. So in that case, it is going to be while in the case of resonance, it is going to be produce the here ultrasonic sounds. So figure is very, very important. Without a drawing figure, we can't give you marks. Is it clear? So let me explain this. Yeah, the frequency of this tank circuit, that is 1 by 2 pi under root LC. Okay. So here, what is L suffix T means? Inductance of tank and in the capacitance of tank. Okay. So here the piezoelectric ultrasonic oscillator, which is containing NPN transistor. So what do you mean by NPN transistor? Hello. Hello.
N, NPN, sir. Formation of the transistor, sir.
Yeah, combination of two transistors, combination of two
Yes, sir,
diodes.
diode. Two diodes, sir.
Two
Very,
diodes.
very good. So that diode is a PN junction diode here. P means a
Yes,
positive,
sir.
N means a negative electrons. Okay.
P means holes.
Positive holes.
Holes to holes. Yes, sir.
Negative electrons. So you don't to say that P is a positive plate, N is a negative.
Yes, sir.
Yes, sir.
So
We
the
can't
charge
say this.
carriers which are to be present inside the P and N, you have to say that PZ,
Yes, sir.
PZ as semiconducting material, N is also semiconducting material, but how it is going to be preparing means here when a trivalent impurity adding P type and a pentavalent impurity which is adding to the Q, that is N type. Majority,
N type.
yeah. So that we will discuss in final years electronics.
Okay.
So here,
Okay, sir.
yeah, NPN means here the symbolic representation of the here is like this. Okay. So let you say that this is emitter, this is base, this is collector here. When the current flow which can flows from the emitter to the base, that is a PNP. Emitter to the base means PNP. Okay. Or else a collector to the base means if it is the current which can flows from the collector to the base is NPN.
NPN.
Yeah. So here they have been used the NPN transistor and here in output part, this is a common emitter configuration. What do you say? Common emitter configuration. That means common emitter means the transistor which contains the emitter
Input
base.
and output.
When emitter is common for input and as well as the output, then type of configuration you can call it as a common emitter configuration. So that you have to mention. Getting my point? So the out part or collector emitter part, there is a tank circuit here. Here, this is the tank circuit. So LT as well as the CT, that means inductance of tank as well as the capacitance of the tank here. As the S is a switch area, as the circuit to switch and electrical energy which can stores in this so that the current which is going to be set up in the coil here until the capacitor gets discharged. So that magnetic energy, that means current carrying conductor may produce the magnetic field. Like that here, the coil, the current is going to be set up means automatically magnetic energy which is going to be in the coil, which increased to a certain value, that is a maximum. And the capacitor starts getting charged in this case up to a value, maximum value, then the electrical energy and the magnetic energy which becomes zero. Why? Because of here that is going to be stored in as well as capacitor as well as in the inductor. So that here LT will have a alternating becomes maximum and minimum values with respect to the electrical as well as the magnetic energies. There should be a cyclic process which is going to be observed, so that for a few cycles, the amplitude as well as the frequency which are going to be disturbed. So in this, it can produce a sustained oscillations. We need to feedback inductance here. We are getting back feedback. That means the fraction of the output which is connected to the input, that is called here feedback. So here inductance, feedback inductance LF. Okay. LT is a inductance of tank circuit. LF is a feedback inductance in the input or base emitter of the circuit here. And NPN transistor which can amplify this current. Amplifying means strengthen the signal here. Is it clear? So in current in the feedback coil and which can gives to the tank circuit. So the currents in LF as well as LT which are in phase, so that which is by the Faraday's law of electromagnetic induction, EMF equals to minus d phi v by dt, Faraday's law. So which the current in secondary coil LS, this one, where here, this is the LS, these are the LP. Okay, this is the feedback and this is the tank and this is the secondary coil. So that these are LS, LF, LT, LS are inductively, these are going to be coupled here. So that a quartz crystal with the two plates, that is A and B, which are connected to the LS here. The natural frequency of the quartz crystal, which is going to be resonating with the frequency of the tank circuit, where it is here. Okay. So that you can able to observe the here the quartz crystal which is going to be producing ultrasonics. So here using this method, piezoelectric method, you can able to get the 500 megahertz up to 500 megahertz. Okay. So this is the formula for this.
ఈ ఫార్ములా సేమ్ మెల్డిస్ ఫార్ములా లాగా ఉంది.
Emma?
ఈ సేమ్ మెల్డిస్ ఫార్ములా లాగా ఉంది సార్.
Yeah. So 1 by 2 pi
2L.
root LC with the tank circuit, that is equals to the here quartz plate. FQ means quartz plate frequency 1 by 2T into root Y by rho. Y by P gadadi, Y by rho. Rho is the density of the quartz crystal. That is the case. That means mechanical stress or strain is to be applied. That means electrically it is going to be produce the ultrasonics in the case of electrostriction method, that is related to the piezoelectric effect. Next is the magnetostriction method. This is the another method which you can able to produce the ultrasonics. So magnetostriction ultrasonic oscillator, which is contain a sufficiently long ferromagnetic rod. So in previously we have been considered piezoelectric, anti-piezoelectric substances. So here a ferromagnetic rod is to be considered. A ferromagnetic materials which can have a domains. Do you know the domains? Hello. Hello. So in
Sir,
magnet, you can able to observe the domains here. Okay. No need to say that I can show you.
Domain means mathematical domain.
Usually you can able to say that domains. So which all the atoms or molecules which are aligned in one direction. So that means in which direction? If you apply magnetic field toward that field only, these domains are going to be aligned here. So that may, which is a magnetic tiny dipole. What do you mean by dipole? డైపోల్ అంటే ఏంటండి? హలో, తెలుగులో ద్విధ్రువము అంటాం. Can you say north and south polar dipoles?
Electronic magnetic.
Electronic magnetic di.
They said
Equal and opposite charge.
ఉత్తర దక్షిణ ధ్రువాలను మనం డైపోల్ అని చెప్పొచ్చా?
Yes, sir.
అవును చెప్పొచ్చు సార్.
Equal and
ఏంటవి?
opposite.
చెప్పొచ్చు సార్. ఎస్ సార్.
That means
South and North Pole.
the magnitude of the two
సౌత్
is
పోల్ నార్త్ పోల్.
the magnitude
opposite
of
signs అని కూడా అనొచ్చు కదా సార్. స్మాల్ డిస్టెన్స్ లో కూడా ఆపోజిట్ సైన్స్ సెపరేటెడ్ బై అ స్మాల్ డిస్టెన్స్.
yes. So here opposite signs అని అనకూడదు కానీ magnitude. So that in the case of magnitude means we need not to be considered here whether it is a positive or a negative. So the magnitude of the opposite charges which are separated by such a distance, you can call it as a dipole.
ఎస్ సార్.
Plus q minus q is there. That means the magnitude q1 and q2 which are separated by such a distance small r. Then that setup is nothing but a dipole. So in the case of here also, so why they are going to be saying here a dipole means here plus and minus, plus and minus, minus plus. So these are the domains here. If you apply a magnetic field, that means if it is a plus plate or minus plate, so that negative like this.
Like remote charger batteries also we
That
can
means,
call.
yeah, negative charges which are attracted by the positive plate and positive which are attracted by the negative. That means the alignment which is going to be set up like this.
ఓకే సార్.
Basics ఉండాలి. Basic చదివితే మీకు ఈజీగా అర్థమైపోతుంది. So the finish. Yeah. So the dipoles in the absence of external magnetic field. There is no magnetic field at all. That means B equals to 0. Those are randomly oriented. So when you apply an external magnetic field, that means the alignment should be in the direction of the magnetic field and which is parallel to the length of the rod. So just now I show you. So if it is found that there is a change in its length. Which length? Ferromagnetic rod length. By applying field and by removing field, you can able to observe there is a slight change in its length. Then this phenomena you can call it as a rod of ferromagnetic material and which undergoes a small change when it is placed in a magnetic field, and the length of the rod which is known as magnetostriction. Okay. So if L is the total length of the rod, when B equals to 0. B0 means there is no magnetic field. So if the field is to be applied here, the length of the rod is going to be changing here. It is to be found here x by L, which is proportional to the B square, or x by L, which is equals to dB square. The D is the proportionality constant here. Suppose if we superimpose an AC magnetic field here over the DC magnetic field with a suitable frequency, you can achieve the length of the rod which is going to be changing here, so that there is a increase or a decrease of the ferromagnetic substance length here. And that means there should be a magnetization as well as the demagnetization. That means when you apply a field, magnetization is to be takes place. If you remove the field, magnetic field, demagnetization is going to be takes place here. That means here whether the length of the rod is going to be increases or decreases, that should be depends upon the applied field, capital B. So that in this case, hence we can get the by changing, increasing or decreasing, magnetization, demagnetization. In this process, you can able to get the ultrasonic waves at other end of the rod here. So you can easily see that here, this is the magnetostriction method. So in this case, NPN transistor is there. Here also CT and LT tank circuit is there. LF, that means here other coil, LS is the secondary coil is there. So switch is there, DC supply is there. So where is the substance? Substance is here only. This is the rod. Okay, this is the rod. So this is the ferromagnetic substance here. So that the length should be increased or the length should be decreased. Okay. Compulsory, figure is compulsory. So here also the same process is to be takes place here. In the case of మనకి ఎలక్ట్రోస్ట్రిక్షన్ మెథడ్ లో ఏదైతే మనం చెప్పడం జరిగిందో అది ఒక్కసారి చూడండి. మీరు చూస్తే లెంత్ ఇంక్రీజ్ అవుతుందా డిక్రీజ్ అవుతుందా అనేటువంటిది చేయవచ్చు. అండ్ బేస్డ్ ఆన్ దట్ సేమ్ ఫార్ములా 1/f equals to 1/2 pi under root LTCT and the natural frequency of the rod. Okay, that is not 1/2t here, k/2l into square root of y by rho. Okay, formula. So by applying this, you can easily find out. So what are the detection of ultrasonic? So 1 minute here. Is it clear? Dig right?
Yes, sir.
Lecture 2.
Yes.
Yeah. There are some difficulties associated with the production of ultrasonic method. So here, the main difficulty, that means about 20 kilohertz ultrasonics has to produce, means the sound waves which can produce by vibrating surfaces. But frequency of high order which cannot be produced by these sound waves. So that here also the natural frequency of a moving parts does not allow the ultrasonic sounds with the ordinary techniques. So ultrasonics cannot be produced by usual method of loudspeakers which can fed through the AC alternating current, because it cannot be vibrate at such high frequencies. Production, mechanical method, piezoelectric, as well as magnetostriction method. So these are the methods, but important is piezoelectric as well as magnetostriction. So here magnetostriction method which is used up to here 100 kilohertz. That means here previously 500 kilohertz they have been calculated, but needed in the case of piezoelectric, this frequency is enough. Piezoelectric effect, generation of ultrasonic wave based on the piezoelectric effect, which was developed by Langevin in 1917. When a piezoelectric material is squeezed or stretched, electrical charge is generated on the its surface. So inverse piezoelectric method is also there. You can able to produce the voltage. So when subjected to an electrical voltage, then a piezoelectric material mechanically deforms. What do you mean by deform? The shape and shape of the crystal which is going to be changes here. Okay, that is a deformed. A piezoelectric materials. So the functional component which can convert the electrical energy into a mechanical energy by physical deformation. Mechanical pressure is applied, its surface creates electrical energy, and mechanically compressed by an externally applied pressure, the alignment of the dipoles, which is disturbed from the equilibrium position to cause an imbalance of the charge distribution. So piezoelectric materials, man-made materials, which are ceramics, barium titaniate, BaTiO3, lead titaniate, zirconate. Lead means Pb, zirconate means Zr, titaniate means TiO3, PZT, which is mostly used to produce the ultrasonics in the case of piezoelectric materials. The composition, shape, and dimensions of the element can be tailored to meet the requirement of specific purpose. Can you see this? These are the piezoelectric ceramics. కనిపిస్తుందండి?
Yes, sir.
Yes, sir.
నెక్స్ట్ పాలిమర్స్ అండి. అంతకుముందు సిరామిక్స్ గురించి మాట్లాడినాం. PVDF అంటాం, పాలివినైల్ ఫ్లోరైడ్. సో piezoelectric composite, a combination of piezoelectric ceramics and polymers to attain properties which cannot be achieved in a single phase. సో సింగిల్ ఫేజ్ లో ఉండవు మనకి. నానో ట్యూబ్స్ లో చూస్తే 1 dimensional 2 dimensional 1D లో మనకి కనపడవు. సో యూ కెన్ ఈజీలీ ఐడెంటిఫై దట్. piezoelectric మెటీరియల్ చూడండి, క్రిస్టల్ ఎట్లా కంప్రెస్ అవుతుంది, ఎలాంగేషన్ అవుతుంది. ఇజ్ ఇట్ క్లియర్? ఈక్విలిబ్రియం లో ఉంది ఎప్పుడైతే మనం సిగ్నల్ పంపించినామో. ఓకే, సో ఈక్విలిబ్రియం, నో సర్ఫేస్ చార్జ్. ఇది ఈక్విలిబ్రియం పొజిషన్. వాట్ ఈస్ దిస్? ఏసీ సిగ్నల్ యు ఆర్ సెండింగ్ టు దిస్. అలైన్మెంట్ కూడా చూసారా, అలైన్మెంట్ ఎట్లా ఉందో. అలైన్మెంట్, నో సర్ఫేస్ చార్జెస్. సర్ఫేస్ మీద ఏమైనా చార్జెస్ ఉన్నాయా? ఇక్కడ లేవు. ఎక్స్పాన్షన్ లో చూసారా, ఎక్స్పాన్షన్ వచ్చినప్పటికీ సర్ఫేస్ మీద, ఒక సర్ఫేస్ మీద ఏం పాజిటివ్, అనదర్ సర్ఫేస్ మీద నెగిటివ్. ఓకే, ఎక్స్పాండ్ అవుతుంది క్రిస్టల్ అనేటువంటిది, దానికి సైజు పెరుగుతుంది. ఇక్కడ కంప్రెస్ అవుతుంది చూడండి, కంప్రెస్
Yes,
వచ్చి
sir.
సరే. సర్ఫేస్ చార్జెస్ ఈస్ గోయింగ్ టు బి అబ్జర్వ్డ్, బట్
Negative, positive.
క్రిస్టల్ విడ్త్ ఈస్ గోయింగ్ టు బి చేంజింగ్ హియర్. అవునా కదా?
Yes, sir.
సో మీరు ఎక్స్పెరిమెంటల్ గా మీరు అబ్జర్వ్ చేస్తే మీకు ఈజీ అవుతుంది. సో నెక్స్ట్ piezoelectric మెథడ్. ఇది యాక్చువల్ గా మీరు నేర్చుకుంటే ఇది నేర్చుకుంటే సరిపోతుంది. వాట్ యూ మీన్ బై piezoelectric ఎఫెక్ట్ అంటే నీకు ఆల్రెడీ చెప్పినాను. దాంట్లో కన్వర్స్ మెథడ్ కూడా ఉన్నది. మనం రెండాట్లకి సంబంధించి డెఫినేషన్ రాసి ఫిగర్ వేసి ఫిగర్ నుంచి మనం రాస్తాము. ఓకే, దిస్ ద కేస్. ఫ్రీక్వెన్సీ కూడా యూ కెన్ ఏబుల్ టు ఐడెంటిఫై. 2.725 మెగాహెర్ట్జ్ అని చెప్పినాం మనం అంతకుముందే. అక్కడేమో ఒక టెక్స్ట్ బుక్ లో ఎఫ్ అన్నాడు, ఇక్కడేమో న్యూ అన్నాడు. నో నీడ్ టు వరీ, న్యూ అండ్ ఎఫ్ బోత్ ఆర్ సేమ్. సో ఈ ఎఫెక్ట్ వచ్చినప్పటికి అడ్వాంటేజెస్ చెప్పినాడు చూడండి. ఇట్ ఈస్ మోర్ ఎఫిషియంట్ దాన్ ది మ్యాగ్నెటోస్ట్రిక్షన్ ఆసిలేటర్, piezoelectric effect. So ultrasonic frequencies as high 5 into 10 power 8 hertz can be obtained. The output of the oscillator is very high. Generator is ineffective to temperature and humidity. Disadvantage వచ్చినప్పటికీ cost of piezoelectric quartz plate is very high, and its cutting and shaping are very complex. అంత ఈజీగా ఏదో మనం కత్తెరతోటి మొత్తం సీజర్ తీసుకొని కట్ చేస్తే వస్తుంది లేకపోతే ఒక బ్లేడ్ తీసుకుని కట్ చేద్దాం అంటే ఇట్ ఈస్ కాంప్లికేటెడ్. ఇఫ్ యూ వాంట్ టు గెట్ ది ఎక్స్ కట్, వై కట్, జెడ్ కట్ హెక్సాగోనల్ షేప్ లో మనకి రావాలి అంటే ఇట్ ఈస్ కాంప్లికేటెడ్. నెక్స్ట్ ఈస్ ది మ్యాగ్నెటోస్ట్రిక్షన్ మెథడ్. సో మ్యాగ్నెటోస్ట్రిక్షన్ మెథడ్ లో ట్రాన్స్డ్యూసర్స్ వాడతామని చెప్పినాం. ఇక్కడ వచ్చినప్పటికీ ఫెర్రో మ్యాగ్నెటిక్ మెటీరియల్ తీసుకుంటాం మనం. ఇందులో వచ్చిన డొమైన్స్ ఉంటాయి. అప్లైడ్ మ్యాగ్నెటిక్ ఫీల్డ్ ఎట్లా ఫెర్రో మ్యాగ్నెటిక్ రాడ్ ఈస్ టు బి కన్సిడర్డ్. This is the construction of this magnetostriction method, where the ultrasonic waves are going to be produced. Where is a tank circuit? Where is NPN transistor is there? You need to find it. So merits వచ్చినప్పటికీ the design of generator is very simple and the cost is low. The ultrasonic at low ultrasonic frequencies, it has a large power output without the risk of damage of oscillators. Demerit కి వచ్చినప్పుడు it cannot be generate ultrasonics of frequencies above 300. అదే మనకి ఫిజో ఎలక్ట్రిక్ లో 500 వరకు వస్తుంది కదండి, అవునా? ఇక్కడ అబౌవ్ 300 kHz వరకు మనము మ్యాగ్నెటోస్ట్రిక్షన్ లో ఇట్ ఈస్ ఇంపాసిబుల్ టు గెట్ అబౌవ్ దట్. ద ఫ్రీక్వెన్సీ ఆఫ్ ఆసిలేషన్ విచ్ కెన్ డిపెండ్స్ ఆన్ ది టెంపరేచర్. టెంపరేచర్ పెరుగుతూ ఉంటే అది మనకి రాడ్ యొక్క షేప్ అనేటువంటిది మారిపోతూ ఉంటుంది. కాబట్టి ఇట్ కెనాట్ బి achieve the oscillations or vibrations. There is a loss of energy due to hysteresis as well as eddy current. That's it. So ఈ 2 questions maximum చూసుకోండి.
ఓకే సార్.
Yeah. So ఇంకా ఉన్నాయి కానీ బట్ టైమ్ ఈజ్ వెరీ లెస్.
సార్
దట్స్ వాట్. మీకు నెక్స్ట్ క్లాస్ ఉందనుకుంటా, ఐ థింక్ సో.
లేదు సార్, ఇది లాస్ట్ క్లాస్ అని
This is
చెప్పారు.
the last class, sir.
ఇదే లాస్ట్ క్లాస్.
అవును సార్. సార్ ఇది ఇప్పుడు ఇంత ముందుకు చూపించిన PDF షార్ట్ ఫామ్ లో ఉంది కదా,
చెప్తాను, పెడతాను,
అది పెట్టండి సార్.
అన్ని పంపిస్తాను. డిటెక్షన్ ఆఫ్ అల్ట్రాసోనిక్స్ లో కొద్దిగా ఫాస్ట్ ఒక 5 minutes తో కంక్లూడ్ చేస్తాను చూడండి.
ఓకే సార్.
అండ్ ఆల్సో అప్లికేషన్స్. డిటెక్షన్ ఆఫ్ అల్ట్రాసోనిక్ వేవ్స్ ఎట్లా మీరు డిటెక్ట్ చేయగలుగుతారు? సౌండ్ వేవ్స్ అయితే వేవ్స్ అయితే ప్రొడ్యూస్ అవుతున్నాయి కదా, అరే ఇవే అల్ట్రాసోనిక్స్ అని మీరు ఎట్లా ఐడెంటిఫై చేస్తారు? సో దీస్ ఆర్ ది మెథడ్స్ హియర్. ఫిజో ఎలక్ట్రిక్ మెథడ్ ఒకటి ఉన్నది హియర్. ఫిజో ఎలక్ట్రిక్ వచ్చినప్పటికే వన్ డైరెక్షన్ లోకి వచ్చినప్పటికీ మనము మెకానికల్ స్ట్రెస్ అప్లై చేస్తుంటే అదర్ డైరెక్షన్ లోకి వచ్చినప్పటికీ చార్జెస్ అక్యుములేట్ అవుతూ ఉంటాయి. చూసారా మీరు? ఆపోజిట్ వచ్చినప్పటికీ పాజిటివ్ ఛార్జ్ ఏమో లెఫ్ట్ సైడ్ ఉంది, నెగిటివ్ ఛార్జ్ రైట్ సైడ్ ఉంది. మనకి ఇక్కడ అల్ట్రాసోనిక్ వేవ్స్ దీనికి పెర్పెండిక్యులర్ గా మనకి ప్రొడ్యూస్ అవుతున్నాయి, అవునా కదా? సో దిస్ ఈస్ ద కేస్ విచ్ యూ హ్యావ్ బీన్ అబ్జర్వ్డ్ ఇన్ ద కేస్ ఆఫ్ ఫిజో ఎలక్ట్రిక్. నెక్స్ట్ కున్స్ ట్యూబ్ అంటాం. KUNDT అపాస్ట్రియస్ క్యూన్స్ ట్యూబ్ మెథడ్. సో ఇక్కడ వచ్చినప్పటికీ పౌడర్ మనము క్యూన్స్ ట్యూబ్ లో అల్ట్రాసోనిక్స్ ని ప్రొడ్యూస్ అవుతున్నాయా లేదా అనేటువంటిది మనం ఇక్కడ లైకోపోడియం పౌడర్ ని స్ప్రింకిల్ చేస్తాం ఇందులో, ఈ ట్యూబ్ లో. సో దానికి ఎప్పుడైతే అల్ట్రాసోనిక్ మనకి జనరేట్ అవుతున్నాయో ద పౌడర్ ఇన్ ది ట్యూబ్ విచ్ కెన్ కలెక్ట్ ది ఫార్మ్ ఆఫ్ హీప్స్. ఓకే, హీప్ అంటే అంత కుప్ప కింద ఒక చోట చేరటం జరుగుతుంది. సో అదర్ ప్లేసెస్ లో యూ కెనాట్ ఏబుల్ టు ఫైండ్ అవుట్. అవునా? చూడండి ఇక్కడ కున్స్ ట్యూబ్కి వచ్చినప్పటికి చూడండి, ఈ ప్లేస్ లో లేదు, మళ్ళీ ఈ ప్లేస్ లో లేదు. సో దిస్ ఇస్ ద లైకోపోడియం పౌడర్. దట్ మీన్స్ మోర్ వైబ్రేషన్స్ ఆర్ టు బి అబ్జర్వ్డ్. మోర్ వైబ్రేషన్స్ ఉంటే నోడ్, అసలు ఏమి వైబ్రేషన్స్ లేకపోతే యాంటీ నోడ్.
Loop lang form.
Yeah. So that you can easily find out the distance between the node and antinode, average distance. అది ఏం చేస్తుంది మనకి, which can gives the λ/2 half of the wavelength. So from that only you can easily identify that వేవ్ లెంత్ పరంగా మనము వాట్ టైప్ ఆఫ్ వేవ్స్ విచ్ ఆర్ గోయింగ్ టు బి జనరేటింగ్. సో దిస్ is the Kunz tube method. Next, sensitive flame method is also there, which is moving in a medium where ultrasonic waves are going to be present. So here also flame, manta. So remain stationary at antinodes. అవునా కదా? నోడ్ దగ్గరకు వచ్చినప్పటికీ ఫ్లిక్కర్స్ వస్తుంటాయి. ఫ్లిక్కరింగ్ క్రాకర్స్ మనం కాల్చినప్పుడు ఫ్లిక్కర్ ఎట్లా వస్తుంది, అట్లా వస్తుంది. సో దట్ ఈస్ ద సెన్సిటివ్ ఫ్లేమ్. నెక్స్ట్, థర్మల్ డిటెక్టర్ మెథడ్. Any of two you can project in the case of detection of ultrasonic waves. So this is the case here. Thermal detector లో temperature variant తోటి మనం చూస్తాం. ఇక్కడ థర్మల్ పరంగా అన్నీ కూడా నోడ్ యాంటీ నోడ్ గురించి మాట్లాడతాం. మోర్ వైబ్రేషన్స్, లెస్సర్ వైబ్రేషన్స్, నో వైబ్రేషన్స్. నెక్స్ట్, అప్లికేషన్స్ పరంగా చూస్తే సో మెనీ కేసెస్ వీఆర్ యూజింగ్ దీస్. అల్ట్రాసోనిక్స్ చూసుకుంటే మెకానికల్ ఇంజనీరింగ్ లో కానీ, కెమికల్ కానీ, మెరైన్ ఇంజనీరింగ్ కానీ, అగ్రికల్చరల్ లో కానీ, ఆప్టికల్, మెడికల్. 1 minute అయిపోయింది, వెళ్ళిపోదాం. సో ఇక్కడ వచ్చినప్పటికీ మీరు యూ నీడ్ నాట్ టు రైట్.
Sir, your voice is not visible, sir.
విజిబుల్ కాదమ్మా, ఆడిబుల్.
Audio.
మీరు ఒకసారి మీ దగ్గరే ప్రాబ్లం అవ్వంటారు. సో ఇక్కడ మీరు
Not audible, sir.
హలో హలో హలో.
Sir, you are audible. Maybe her side there is problem.
Okay. So here mechanical energy engineering, chemical engineering, so electrical engineering, environmental, medical engineering. That means you need to give one example for that. Okay. Optical engineering. So by writing and give at least 1 or 2. So definitely you will get the maybe if it is a 4 marks question or 8 mark question, complete 4 out of 4, 8 out of 8 you will get it. Applications. Okay. So here NDT testing, that is most important here. Non-destructive testing here. And evolution, macro. Here we are good. So here ultrasonic applications లో చూస్తే ఇక్కడ మనం instrumentation లో what are the instruments we are using here, what type of method we are using here. NDT, non-destructive testing లో కానీ, evolution లో కానీ, what are the objects. So method, different method, macrosonics. So here cleaning metal parts of instruments, medical equipment, flaw detection. ఏమన్నా ఫ్లా డిటెక్షన్ మెటలర్జీ చూస్తాం, తెలుసు కదా. ఏమన్నా మనం పెద్ద పెద్ద
Yes, sir. Yes, sir.
చిన్నగా పగుళ్ళు ఏర్పడినాయా లేదా అనేటువంటి దానికి అల్ట్రాసోనిక్ వేవ్స్ మనం పంపించి ఈజీగా ఐడెంటిఫై చేయొచ్చు. రైల్వేస్ లో కానీ, ఐరన్ రోప్స్ లో కానీ, ఇన్ సైంటిఫిక్ రీసెర్చ్, మెడికల్ ఫీల్డ్, జస్ట్ నౌ సోనోగ్రామ్, అల్ట్రాసోనిక్ స్కానింగ్ చేసుకురమ్మంటారు ఏమైనా ప్రాబ్లం అంటే. సో దే ఆర్ యూజింగ్ దీస్ ultrasonics. Applications, drilling of holes so that there, or if you want to cut a any iron rod like this, there we are using ultrasonic cleaning. At least give small examples.
Metal, sir.
Yeah. So here you can easily identify that is there any flaw detector is there, so which is running on the track of the railways. So it is going to be identifying that. So portable ultrasonic flaw detector.
Sir, this machine used for cracks, sir?
అంతే కదా. ఏమన్నా ఆ మెటీరియల్ లో మనకి ఐరన్ మెటీరియల్ లో ఏమన్నా ఎనీ క్రాక్స్ ఆర్ దేర్, ఈజీలీ.
Okay, sir. Thank you. Okay, sir.
సో మెడికల్ అప్లికేషన్స్ లో మనకి అల్ట్రాసౌండ్ అందరికి ఇది చాలా
తెలిసినట్టు.
అందరం కూడా వెళ్ళాము. మెడికల్ అప్లికేషన్స్ ఆఫ్ అల్ట్రాసౌండ్స్, సోనోగ్రామ్ ఆఫ్ నార్మల్ హార్ట్.
ఓకే సార్.
సో నార్మల్ కిడ్నీ. ఓకే,
ఓకే సార్.
ఇవన్నీ మీకు టెక్స్ట్ బుక్ లో లేవు.
అవును సార్, అందుకే సార్ మిమ్మల్ని
ఇవన్నీ
అడుగుతున్నాం.
ఇవన్నీ గీసారు.
లేదు
సార్
సార్,
సార్ ఇది
పంపండి సార్
ఏమంటారా బాబు అని.
కొంచెం ఇంపార్టెంట్ క్వశ్చన్ షేర్ చేయరా సార్?
చెప్తా మీకు.
ఓకే
ఓ రోజు
ఓకే సార్.
ఓ రోజు జూమ్ మీటింగ్ పెట్టుకుని మీకు ఎగ్జామ్ ఎప్పుడో చెప్తే ఒక 10 days 15 days ముందే చెప్తే దెన్ ఐ విల్ టెల్ యూ.
October 28th.
అక్టోబర్ 28th.
28 నుంచి స్టార్ట్ సార్, కానీ 3rd కో 4th కో ఉంది సార్ ఎగ్జామ్. అంటే కొంతమందికి 3rd కి, కొంతమందికి 4th కి ఉంది.
4th ఉంది సార్ కర్నూలులో.
ఎస్ సార్, 4th సార్.
ఓకే, అక్టోబర్ 4th.
అవును సార్.
November
నో
4th.
నవంబర్.
నవంబర్ 4th కదా.
సార్, అక్టోబర్ 23rd నుంచి స్టార్ట్ సార్.
ఓకే,
ఎస్ అవును సార్.
చెప్తాను మీకు ఒక
15 or 20, sir, if you guide something to us, it will be better.
before that only I will take a class. So
Yes,
there
sir.
we can discuss the important. And these materials also I am going to share.
థ్యాంక్ యూ సార్.
You can go through that.
ఓకే సార్.
You can read it well. Don't copy. I am easily identifying
Okay,
who is copying and who is not copying. If the fellow is copying, if the fellow is copying from the textbook or material, the page number as well as the if it is any refer to page number 60 means that is also going to be writing. So how intelligent he is, he or she. That is the case I am observing. So
సో అవర్ సెంటర్ వాజ్ వెరీ స్ట్రిక్ట్ సార్.
which center amma?
ఎస్పీ కాలేజ్ సార్.
Yes, Sikandrabad.
ఎస్ సార్, పద్మరావు నగర్.
SP College, Sikandrabad.
Okay,
వెరీ స్ట్రిక్ట్ సార్.
very good. చదివితేనే కదా.
ఖైరతాబాద్ ఆల్సో సార్.
ఇన్ కర్నూలు ఆల్సో సార్.
ఓకే, సిటీ కాలేజ్ ఎవరు లేరా?
ఎందుకు సార్, చీటింగ్ లేదా?
సిటీ కాలేజ్ కూడా స్ట్రిక్ట్ అయింది ఇప్పుడు, లేదు అక్కడ సెంటర్ కూడా లేదు.
ఓ
ఓకే, మనం చీటింగ్ కాదు కానీ ఎంతో కొంత నాలెడ్జ్ గెయిన్ చేసుకుంటే we can easily
Yes, sir.
ఓకేనా?
ఓకే సార్.
Sir.
సో నా
Yes, sir.
రైట్, ఆల్ ది బెస్ట్.
థ్యాంక్
Thank
యూ
you,
సార్.
sir.
సార్ నెంబర్ సార్.
యా, టెల్ మీ.
డౌట్
సార్
అంటే
Number, sir.
షేర్ ఎలా చేస్తారు
What
సార్?
is your doubt? Tell me.
గ్రూప్ ఉంది, గ్రూప్.
అచ్చా, గ్రూప్ ఉందండి.
వినోద్జీని,
ఓకే ఓకే.
వినోద్జీకి నంబర్ ఇవ్వండి.
అచ్చా ఓకే అండి. ఓకే అండి.
Also, few videos are there in our website which I have posted. My videos are there. Go through that videos. You can easily identify.
సార్ లింక్
అంబేద్కర్ దాంట్లోనే ఉన్నాయి. యూట్యూబ్ లో కొట్టినా కూడా
సార్ చాలా లింక్స్ వస్తున్నాయి సార్, మేము వెతకలేకపోతున్నాం.
నా పేరు కొట్టండి, డాక్టర్ వి శ్రీనివాసరావు.
షూర్ సార్. ఓకే సార్.
రైట్, ఆల్ ది బెస్ట్.
థ్యాంక్ యూ సో మచ్.
Thank you, sir. Thank you, sir.
థ్యాంక్ యూ సార్.
థ్యాంక్ యూ సార్. థ్యాంక్ యూ సార్.
రైట్.
ఎవ్రీవన్ గ్రూప్ లో జాయిన్ అవ్వాలి అంటే వినోద్జీ నెంబర్ పెట్టారు, జాయిన్ అవ్వచ్చు.
Okay. Bye-bye.
బాయ్ వినోద్జీ.
Bye.
ఓకే సార్. ఓకే వినోద్ బాయ్, బాయ్. థ్యాంక్ యూ.
खत्म